duplicated or triplicated or whatever the case may be. Okay. What Thad brought up was the ending "-nig". So when you see trisomic or tetrasomic, etc., these are versions of what's called aneuploid. So this, when you see the root or the suffix aneuploid, so these are both examples of trisomic, tetrasomic, octosomic, whatever you put with a different beginning on the word. But aneuploid means that you have an abnormal number of chromosomes and it's not the entire genome equally duplicated. Okay, so this is an abnormal number, again. But it's more correct to say individual. So each individual chromosome is present in an abnormal number. So that would be like trisomy 21, where, or my trisomic 16 chicken line I told you guys about. All their other chromosomes in those chickens, the chromosome 1 is diploid, has 2 copies, 2 diploid, 3 is diploid. Everybody but 16 all of a sudden has 3 copies. So only one of the chromosomes is abnormal. You would also be aneuploid if you had, I don't know, 3 copies of your 16, 4 copies of number 2, 8 copies of 20. If you had some unbalanced, crazy number beyond diploid, that's an aneuploid individual or cell. Okay. We don't really see aneuploid individuals all that often in nature, and when you do, there are phenotypic consequences like you guys have seen with trisomy 21. So does the difference between polyploid and then aneuploid make sense? And to say trisomic is not the same as saying triploid. Very different. Yeah. And that's why we would call the cell or that genome or that individual a triploid, and then that's it. That's how you would use the nomenclature. Whereas trisomic, you would say trisomic 16, trisomic 21. You would have to indicate what chromosome. The whole cell is aneuploid, but you would then say it's tetrasomic 2, trisomic 3, 4, whatever the chromosome. You're indicating what chromosome is in an abnormal number. Okay. We tend to see in humans, other than the aneuploid 21, what's the other aneuploidy that we see? Which chromosome? Besides 21. That's chicken. Yeah, not the sex chromosomes, right? Yeah, so you tend to see more of this, like we talked about the calico cat, the XXY. So this is an aneuploid. So you have one chromosome that's out of whack in terms of its diploidy is not there. There's X, Y, Y, triple X, and then just X by itself. So this top one's called Klinefelters. And these are all named after, well, the first 2 are named after key cases of individuals that these were found in. But I'm not interested in you guys, so this is a monosomy. I'm not interested in you guys memorizing that Klinefelters is XXY, Jacobs is XYY. You can look that information up. But I wanted you guys to see, especially the concept that it's more tolerated, especially in humans, because we talked about other organisms that have a whole entire genome that's duplicated or whatever, or aneuploid differences where you have genetic material that's unbalanced, right? And it's much more tolerated in humans in the sex chromosomes than it is in an autosome. Okay? So this is, we see this, right? More common in the sex chromosomes than autosomes. Why might that be? Yeah, because of dosage compensation, we talked about X inactivation. So this is in part tolerated well. Having an XXY individual is tolerated pretty well phenotypically, not huge consequences, because you have that X inactivation that occurs in these individuals. So then they're back, in terms of expression, they're back down to just an XY. And the other reason, so that's your X chromosome, the other reason is the Y chromosome has few genes on it, right? Not that many genes contributing towards the phenotype. So in terms of having an abnormal, having 3 copies of your chromosome 12, you might have way bigger phenotypic consequence to the point of embryonic lethal miscarriage, where you wouldn't even see those individuals out in the population the way we're categorizing this. So oftentimes we see genetic abnormalities at what seems to be a higher rate only because those individuals are able to grow and develop fairly normally. Okay. And then all the other really strange chromosomal changes and abnormalities, they don't make it past the first few cell divisions in terms of after fertilization. So we wouldn't even see those in the population because it would just show up as in the mother as a miscarriage, and that would be the end of it, unless you did further genetic testing to see what was going on with her or with the zygote. And all of these folks have varying levels of fertility issues, because that's where you can see there might be an issue at meiosis, trying to create viable gametes from a triploid cell. That means you're always going to have one cell that's has an abnormal number of chromosomes. They also have, because of the X chromosome abnormalities, you tend to have some cognitive disabilities and developmental things that occur with some of these to different degrees as well. I know your textbook, but I know that lots of genetics textbooks go on about the phenotypes and stuff. Again, I don't want you guys to memorize what this phenotype is with this condition. It's just interesting to see some of the human possibilities that are out there. So this is where another place that we see aneuploidy in our human population. And in terms of both trisomic 21 and the sex chromosome aneuploidy, in terms of the causes, it turns out the age of the mother plays the biggest role. And I can still remember sitting in my first genetics course as an undergraduate and seeing this chart they put up there, and the chart hasn't changed. And the professor actually put it up on the overhead, and as a woman, I'm looking at the chart, I'm like, oh, okay, no problem. So now, as the years and years have gone on, I keep looking at this chart, and it's like, it's in your textbook, because every textbook has it, and it's like this, exponential, and it has the age of the mother down here, right? And as you're going along into your, 30s and 40s and whatever, it just completely, the probability skyrockets. It's actually quite impressive in terms of statistic measure. But it's very depressing as a woman who's on that way straight upwards curve, because it's like, oh, okay, well, that's great. All my children will be totally disadvantaged. So, why would this be? We'll end our talk tonight here. Why is the age of the mother? Why not the father? Something about the eggs. The eggs are old. Eggs are old. Here, my eggs, right there. right there. What about men? When men get older, is their sperm not old? So this comes down to the biology. Women, your eggs are created as a zygote. Okay? They're held in suspension. So eggs are held at what of meiosis? What stage? Does anybody happen to know?
At the end of M1.
Yeah, it's prophase 1. Yeah, so they're actually held all the way at the very first stage of meiosis, which is pretty incredible to think about that, okay? So your eggs are created, held at prophase 1, and then they just wait. And at each monthly ovulation, they finish going through meiosis 1, meiosis 2, and continue along. Well, as we get older, all the proteins and cellular mechanisms that are involved with meiosis get kind of crappy and lazy, and they just, you see more errors, you see more cell cycle checkpoints being blown. And so the fact that when we say they're old, what that really means, you guys can kind of understand this better now that you know meiosis so well, they're stuck kind of in cryo-freeze at prophase 1. And so as we get older, we don't do meiosis and mitosis so well. Okay, things start to go wrong with that. And in men, sperm are made continuously. Okay, throughout their lifetime, new sperm are made. So it's a much different process, biologically speaking. And it has big genetic consequences, like this probability for most common one that is tracked is our trisomic 21. Okay. And the reason, and we're going to get to this next time, so this leads to, okay, so when there are errors, you get non-disjunction. And we'll talk about non-disjunction next time. And I won't show you the chart, so any women sitting in the crowd don't have to look at the chart and think, well, clock is ticking. Remember to pull your homework out if you didn't already and bring that to me up front.